Well, as you can see, an electroscope is an early scientific instrument used to detect the presence of electric charge on a body. So the third method of the transfer of electrons in electrostatics is called induction. So induction involves this tool you can see here called an electroscope. So an electroscope can actually sense or detect that there's a presence of an electric charge, be it negative or positive. So here we're going to actually look at how does this work and actually what is the third method in which electrons can be transferred. Welcome to Edu-ca-te. So here electrons can be transferred when you can take an electroscope. For example, let me just draw this electroscope over here. So this is my electroscope. So electroscope contains a number of charges. So an electroscope has got what? Has got electrons as well as protons. So an electroscope, it is always neutral, meaning that the number of protons and electrons is equal to one another. So here, how does induction work? So induction work when you have got an object here. For example, let's take this as an object. So this object has got here we can say that this object, it is positively charged, since we can see those number of protons. There are many protons. You cannot see any electron over there, so we can say that is what? Negatively charged. But then how is the electroscope actually involved in this process? So this is what happens with an electroscope. So electroscope having an equal number of electrons and protons. For example, here, let's say here on the electroscope we're having 7 protons and 7 electrons. So what happens is that the electrons are scattered all around over here as well as the protons. So the charges of an electroscope are all around the electroscope itself. So what happens here is that when you bring out this charge, here is positive charge. So when this charge comes over there with protons, what will happen is that all the protons of the electroscope will actually stand in this line, will actually go down there. They're actually repulsive forces between protons and protons. These are two positive charges. Remember that in our introduction to electrostatics, we mentioned that positive charges attract negative charges. So here, the positive charges are the protons, therefore they will do what? They will attract the negative charges. Can you see here the behavior of the what? Of the protons. They are all what? They are all repulsive. So it means that they are actually not attracted to the positives. Like charges do not attract each other, remember? So the protons are actually running away from what? From the top of the electroscope. So what will happen here? What will happen here is that these protons will actually run away over there, and then these ones as well will run away over there. So can you see that the protons have actually been pushed away because of this positive charge coming through in that object? So what will happen then? Remember that the positive charges want the negative charges, not the positive ones. I hope I make myself clear over there. So here, the electrons, which are the negative charges, will actually come closer, and closer. So if an electron was here, it will actually move and until it gets closer to the positive charges. So an electroscope is actually used to actually determine or to actually detect if there's a presence of if there's a presence of an electric charge in an object. So here, the electroscope, by just seeing these electrons lining up, this tells us that this charge over here is positive. So this is how that tool, that instrument called an electroscope works. So what if we bring out a negative charge? So if we are going to bring out a negative charge over there, let's say this is no longer positive, it is now negative. So by negative charge, so it means that it is negatively charged, meaning that it has got more electrons than protons. So here, there are electrons all lining up. So what will happen to those red electrons? Can you see those red electrons? They actually want to get attracted. But no, they will actually run away because those are like charges compared to the charges that are coming with this object over here. So this object A over there, it is coming with what? With electrons. So the electrons, since they are like charges, they will run away. So what? Let's just make them run away right now. So here, they'll do what? They will go down over there, go down over there. Why are they actually going down over there? It is because they are being not attracted. They're actually being pushed away by object A, which contains more electrons. So they will actually line up here. The electrons will actually line up here, actually running away. So what will happen to the protons then? Remember that the protons are actually interested in the electrons. So all the protons will actually go over there. So the protons, because they are attracted, they will actually go over there. Slowly but surely, they will go and reach over there. Here you can see that the protons are actually being attracted by that object A, which contains what? Which contains electron. So the whole point of an electroscope is to detect what kind of electric charge do we have in an object. So this is the third method in which electrons can be transferred from one object to another. It is called induction. Don't forget to stay tuned and subscribe.